Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and in this segment, I'm going to talk about BIM. Yes, this segment, I'm going to talk about BIM. Now, what is BIM? BIM is the acronym for Building Information Modeling. And building information modeling is a process supported by various tools, technologies, and contracts involving the generation and management of digital representations of physical and functional characteristics of places. Building information models are files, often but not always using proprietary formats and containing proprietary data, which can be extracted, exchanged, and networked to support decision making regarding a built asset. Now, current BIM software is used by individuals, businesses, and government agencies who plan, design, construct, operate, and maintain diverse physical infrastructures such as water, refuse, electricity, gas, communication utilities, roads, railways, bridges, ports, and tunnels. Now, how did BIM originate? Well, the concept of BIM has existed since the 1970s. The term building model, in the sense of BIM as used today, was first used in papers in the mid 1980s. In a 1985 paper by Simon Ruffel, eventually published in 1986, and later in a 1986 paper by Robert H., then at GMW Computers Limited, developer of RUCAPS software, we call it RUCAP software, referring to the software's use at London's Heathrow Airport. The term building information model first appeared in 1992. And in 1992, it was a paper done by G.A. van Nederveen and F.P. Tolman. However, the terms building information model and building information modeling, including the acronym BIM, did not become properly used until some 10 years later. And that 10 years later was 2002. Now, in 2002, Autodesk released a white paper entitled Building Information Modeling, and other software vendors also started to assert their involvement in the field by hosting contributions from Autodesk, Bentley Systems, and Graphisoft, plus other industry observers in 2003. Now, Jerry Lazarin helped popularize and standardize the term as a common core for the digital representation of the building process. Facility exchange and interoperability of information in digital format had previously been offered, differing terminology by Graphisoft as virtual building, Bentley Systems as integrated project models, and by Autodesk or Vectorworks as building information modeling. Now, the pioneering role of applications such as RUCAPS, Sonata, and Reflex have been recognized by Lazarin as well as the UK's Royal Academy of Engineering. Now, as Graphisoft had been developing such solutions for longer than its competitors, Lazarin regarded its ArchiCAD application as then one of the most mature BIM solutions on the market. Following its launch in 1987, ArchiCAD became regarded by some of the first implementation of BIM, as it was the first CAD product on a personal computer able to create both 2D and 3D geometry, as well as the first commercial BIM product for personal computers. Now, the U.S. National Building Information Model Standard Project Community has the following definition. Building information model is a digital representation of physical and functional characteristics of a facility. A BIM is a shared knowledge resource for information about a facility, forming a reliable basis for decisions during its life cycle, defined as existing from earliest conception to demolition. Now, traditional building design was largely reliant upon two-dimensional technical drawings, and we're talking about plans, elevations, sections, etc. Again, 2D drawings, and this is where you get AutoCAD. And in 2D, you get plans, elevations, sections, etc. Now, building information modeling extends beyond 3D, argumenting the three primary spatial dimensions: width, height, and depth, with time as the fourth dimension, or we call it 4D. Now, there is a fifth dimension, and that's cost. Now, there are also references to additional dimensions or uses, so-called 6D representing building, environmental, and sustainability analysis, and 7D for life cycle facility management aspect, although they are conflicting definitions. Now, BIM therefore covers more than just one geometry. It also covers spatial relationships, light analysis, geographic information, and quantities and properties of building components, for example, manufacturer's details. Now, BIM involves representing a design as combinations of objects, vague and undefined, generic or product-specific, solid shapes, or void space-oriented, like the shape of a room, that carry their geometry, relations, and object instance. Bim software also defines objects parametrically. That is, the objects are defined as parameters in relations to other objects, so that if a related object is amended, dependent ones will automatically also change. Now, each model element can carry attributes for selecting and ordering them automatically, providing cost estimates as well as material tracking and ordering. Now, for the professionals involved in a project, let me make a correction. For the professionals that are involved in a project, BIM enables a virtual information model to be handed from the design team, and people who are on the design team are your architects, landscape architects, surveyors, civil, structural, and building services engineers. Now, a building services engineer in England is compared to an architectural engineer here in the United States. They do the same job, but the name is different. Now, they go from the design team to the main contractor and subcontractors, and then to the owner-operator. Now, each professional adds discipline-specific data to the single shared model. This reduces information losses that traditionally occurred when a new team takes ownership of a project, and provides more extensive information to the owners of complex structures. Now, BIM throughout the lifestyle. Now, use of BIM goes beyond the planning and design phase of a project, extending through the building life cycle. The supporting processes of the building life cycle management includes cost management, construction management, project management, facility operation, and application in green buildings. Now, we also have management of building information models. Now, building information models span the whole concept to occupation time span to ensure efficient management of information processes through the span. A BIM management, we call him a BIM manager. Also, he's referred to as a virtual design to construction VDC project manager, or VDC PM might be appointed. Now, the BIM manager is retained by the design build team on the client's behalf from the pre-design phase onwards to develop and track the object-oriented BIM against predicted and measured performance objectives, supporting multidisciplinary building information models that drive analysis, schedules, takeoffs, and logistics. Now, companies are also now considering developing BIMs in various levels of detail, since depending on the application of BIM, more or less detail is needed. and there is varying modeling effort associated with generating building information models at different levels of detail. Now, I work in construction as a civil engineer, so what about BIM and construction management? Well, participants in the building process are constantly challenged to deliver successful projects despite tight budgets, limiting manpower, accelerating schedules, and limiting or conflicting information. Now, the significant disciplines such as architectural, structural, and MEP designs should be well coordinated, as two things can't take place at the same place and time. BIM additionally is able to aid in collision detection, identifying the exact location of discrepancies. Now, the BIM concept emphasizes virtual construction of a facility prior to its actual physical construction in order to reduce uncertainty, improve safety, work out problems, and simulate and analyze potential impacts. Subcontractors from every trade can input critical information into the model before beginning construction, with opportunities to prefabricate or pre-assemble some systems off-site. Now, they do this, why? Because waste can be minimized on-site and products delivered on a just-in-time basis rather than being stockpiled on-site. Now, JIT, just-in-time. You always hear that term in industrial engineering, because industrial engineering deals with a lot of budgets, cost estimating as well. They deal with a lot of lean production. Well, in construction, it's called lean construction. Now, quantities and shared properties of materials can be extracted easily because scopes of work can be isolated and defined. Systems, assemblies, and sequences can be shown in a relative scale with the entire facility or group of facilities. BIM also presents errors by enabling conflict or clash detection, whereby the computer model visually highlights to the team where parts of the building, example, structural frame and building services, pipes, or ducts, may wrongly intersect. Again, you deal with any project, you're going to have different parts of the project. So when we talk about clash detection, you see in a building, it will help eliminate problems dealing with the structural frame, building services, pipes, and ducts. Why? Because on any drawing or any plans, they can be drawn wrong. And clash detection by use of BIM eliminates that. Now, BIM can bridge the information loss associated with handling a project from design team to construction team and to building owner operator by allowing each group to add to and reference back to all the information they acquired during the period of contribution to the BIM model. This can yield benefits to the facility owner or operator. For example, a building operator may find evidence of a leak in his building. Rather than exploring the physical building, he may turn to the model and see that a water valve is located in the suspect location. He can also have in the model the specific valve size, manufacturer, part number, and other information ever researched in the past, pending adequate computing power, such powers or such problems. Now, we do have power with the software, but when it comes to software, you have to understand software comes and goes. And what I mean comes and goes, out with the old and in with the new. The problem with software is it gets updated all the time. That's the problem. So such problems when it comes to the software were initially addressed by Leet and Kinsey when developing a vulnerability representation of a facility contents and threats for supporting the identification of vulnerabilities in building emergencies. Now, dynamic information about the building, such as sensor measurements and control systems from the building systems, can also be imported within Bim software to support analysis of building operation and maintenance. There have been attempts at creating information models for old and pre-existing facilities. Approaches include referencing key metrics such as the facility condition index, known as FCI, or by using 3D laser scanning surveys and photogrammetry techniques, both separately or in combination, to capture accurate measurements of the asset that can be used as the basis for the model. Now, trying to model a building constructed, let's say, in 1927 requires numerous assumptions about design standards, building codes, construction methods, materials, and is therefore more complex than building a model during design. Now, one of the challenges to the proper maintenance and management of existing facilities, again, one of the challenges to the proper maintenance and management of existing facilities is understanding how BIM can be utilized to support holistic understanding and implementation of building management practices and cost of ownership, principles that support the full product cycle of a building. Now, an American national standard entitled APPA 1000, Total Cost of Ownership for Facilities Asset Management, incorporates BIM to factor in a variety of critical requirements and costs over the life cycle of the building. And when I talk about life cycle, it's how long the building has got. That's life cycle of a building, not lifestyle. Life cycle of a building. I apologize, I'm making my fair share of mistakes tonight, but I still want you to understand this information. So again, APPA 1000 is the total cost of ownership for facilities asset management, and it incorporates BIM into a factor of critical requirements and cost over the life cycle of the building, including but not limited to replacement of energy, utility, and safety systems, continual maintenance of the building exterior and interior, and replacement of materials, updates to design and functionality, and recapitalization costs. Now, what about Bim and Green Building? Well, Bim and Green Building, or we call it Green BIM, is a process that can help architecture, engineering, and construction firms to increase sustainability in the construction industry. It can allow architects and engineers to integrate and analyze environmental issues in their design over the life cycle of a building. This is where you get into what we call your 6 and 7 dimensions. They deal with sustainability and environmental. Now, Bim software. Now, Bim software has been around since the late 1970s. Now, the first software tools developed for modeling buildings emerged in the late 1970s and early 1980s and included workstation products such as Chuck Eastman's Building Description System and Glide, RuCaps, Sonata, Reflex, and Gable 4D series. The early applications and the hardware needed to run them were very expensive, which limited widespread adoption. So ArchiCAD's Raider CH, released in 1984, was the first modeling software made available on a personal computer. Now, due to the complexity of gathering all the relevant information when working with BIM on a building project, some companies have developed software designed specifically to work in the BIM framework. These packages differ from architectural drafting tools such as AutoCAD by allowing the addition of further information. That's time, cost, manufacturer's details, sustainability, and maintenance information to the building model. Now, non-proprietary or open BIM standards. BIM is often associated with industry foundation classes known as IFCs and ACE XML or AEC XML, data structures for representing information. Now, IFCs have been developed by Building Smart, the former International Alliance for Interoperability, as a neutral, non-proprietary, or open standard for sharing BIM data among different software applications. Now, some proprietary data structures have been developed by CAD vendors incorporating BIM into their software. So, poor software interoperability has been long regarded as an obstacle to the industry efficiency in general and to BIM adoption in particular. Now, in August 2004, a U.S. National Institute of Standards and Technology, known as NIST, they're out of Maryland, their report conservatively estimated that 15.8 billion was lost annually by the U.S. capital facilities industry due to inadequate interoperability arising from the highly fragmented nature of the industry. Now, the industry's continued paper-based business practices, a lack of standardization, and inconsistent technology adoption among stakeholders. Now, an early example of a natural approved BIM standard is the AISC, that's the American Institute of Steel Construction, approved CIS/2 standard, which is a non-proprietary standard with its roots in the NK. Now, of course, international BIM developments, well, BIM has been overseas for a long time. Now, when we talk about BIM software, of course you hear ArchiCAD, but the one that Autodesk has been working with for a little bit is called Revit. In fact, I just finished doing a Revit project. Now, with Revit, what that does, it cuts down on time. Where when you utilize AutoCAD is a coordinate-based software. Everything is set up on a coordinate system. Now, Revit, when you draw a building in Revit, you don't have to draw it perfectly, but you can always change the dimensions so your building will fit. And with Revit, you can do a lot with Revit. You can put terrain on a house. You can put furniture in the house, windows. There's a lot of information. And if you're interested in taking some design courses, I would check your local community college, because BIM is going to be the wave of the future. Now, building information modeling is architect's inventor, because for everybody who's doing mechanical drafting, their 3D software, they're using Fusion and they're using Inventor. I've also used that as well. Over on the architect side, they're using Revit and 360. Now, some of the countries that are involved with building information developments: China, Hong Kong, India, Iran, Malaysia, Singapore, Japan, South Korea, United Arab Emirates. Okay, in Europe, you have Austria, Czech Republic, Estonia, France, Germany, Ireland, Italy, Lithuania, the Netherlands, Norway, Poland, Portugal, Russia, Slovakia, Spain, Switzerland, United Kingdom, of course, in North America, it's Canada, and USA, Africa, Nigeria, South Africa, Oceania, which is Australia, New England, and anticipated future potential. BIM is a relatively new technology in an industry that's typically slow to adopt change, yet many early adopters are confident that BIM will grow to play an even more crucial role in building documentation. Proponents claim that BIM offers improved visualization, improved productivity due to easy retrieval of information, increased coordination of construction documents, embedding and linking of virtual information such as vendors for specific materials, location of details, and quantities required for estimation and tendering, increased speed of delivery, reduced cost. BIM also contains most of the data needed for building performance analysis. The building properties in BIM can be used automatically to create the input file for building performance simulation and save a significant amount of time and effort. Moreover, automation of the process reduces errors and mismatches in the building performance simulation process. Green Building XML or GBXML is a emergent schema which is a subset of the building information modeling efforts focused on the green building design and operation. GBXML is used to input in several energy simulation engines. Now, with the development of modern computer technology, a large number of building performance simulation tools are now available. So when choosing such simulation tool to use, the user must consider the tool's accuracy and reliability, considering the building information that they have at hand, which will serve as input for the tool. Yesiaro, Dong, and Leet developed an artificial intelligence approach towards assessing building performance simulation results and found that the more detailed simulation tools have the best simulation performance in the terms of heating and cooling electricity consumption within 3% of mean absolute error. And that concludes this segment of BIM, Building Information Modeling, here on the Mind of STEM channel. And on this channel, you get a daily dose of science, technology, engineering, and math. And if you like what I just presented, please comment, share, and subscribe. Again, this channel, please subscribe to the Mind of STEM channel. I'm giving you a daily dose of science, technology, engineering, and math. And also, you can check out my other channels, the 401 Talk Zone Radio Show on YouTube and Blog Talk Radio. And if you can't find me on YouTube and Blog Talk Radio, you can find me on Twitter and Facebook. I upload videos once every week. So continue to support this channel. You'll get a lot of information because information is powerful. And again, thank you for listening to tonight's lesson in BIM right here on the Mind of STEM channel. Once again, my name is Leon Jones. God bless you and good night.